All right. Okay. So now that we've restarted this one today, again, we have to say hi to Danielle.
Hi, Danielle.
Okay. All right. There we go. All right. So today we're going to be graphing absolute value equations. So again, you should have picked up a pink piece of graph paper because we will be graphing. Again, totally up to you if you want to take all of your notes on that paper. If you run out of space and need to come up and grab more, I always have more for you. If you want to take notes in your notebook, a regular old piece of paper, and then just, if you even wanted to cut out and paste and all that stuff, whatever, you do you. I'm just going to stand up here and look pretty 24/7, 365.25. Okay? So that way it factors in leap year rather.
Isn't this upcoming year?
20 is a leap year, yes. Yes. Okay. So, this is what our parent functions are sometimes, we call it, in math work, it's called the parent function. We always call it a mother function. Okay? Okay? Because it's fun to say mother function. Okay?
Yeah.
So, this is what an absolute value equation graph looks like. Okay? So, let's talk about it. What do you notice about the absolute value of x, which is this? That is what this is graphed here. What do we notice about the absolute value graph? Talk to me, Jasmine. I saw you give me a hand motion. Luckily, it wasn't just a finger.
Like it says this way, and then it hits the origin.
Yeah.
Sorry, and then it kind of bounces.
Okay.
Off.
So what was the hand motion that you made?
Looks like a V.
Looks like a V. That's exactly what I was looking for right there. It looks like a V. Okay. All absolute value functions will look like a V. Okay? Sometimes your V will be normal. Sometimes your V will be an elementary kid's mountain. Okay? You know what I'm talking about, Raz? Okay. Love it. What else do we notice? From all of your math classes. What do you got? It's reflected. Yeah, very much so. That was the one I wasn't expecting to get. Oops, not going to fit. Biscuits and gravy. It's a reflection. Yes, love it. What else? What do you got? So if it's a V, it's going to be a minimum. Okay. If it's a mountain, it's going to be a maximum. Okay. And that maximum point or that minimum point, we'll put right there. Okay. That we are going to call the vertex. And I use the vertex lightly. I'm even going to put it in air quotes. Because it's truly not a vertex, but it acts just like a vertex from back when you were in Algebra 2 and you were dealing with parabolas and that kind of thing. So yeah, I like it. Anything else? What about the sides of our V or of our mountain? What? They are not equal. Or what do you mean that? Or I should say, I'm confused. What do you mean by equal? Okay, I won't. Well, Jazz, you were saying something? They go on forever and ever and ever? So we should put arrowheads on the end? Yeah, that's okay. Yeah, so what do they look like? What do you mean one's going down and one's going up? What part of it is negative and what part of it is positive? You're getting there. The slope. Yep, one's got a positive slope, one's got a negative slope. Okay. So one's positive, one's negative. Hey, what you got? In this particular case, they are perpendicular, but that is not always the case. Okay? Only in the mother function will they be perpendicular. Yeah. So I don't want to put that one down, but yes, in this particular case, they actually are perpendicular because positive 1 is the opposite reciprocal of negative 1. So yeah, here they are. But this is the only time that happens. Okay? Good? Love it. All right, so we are going to come up with 2 different ways to graph an absolute value. Okay? And frankly, I don't care which method you choose. Okay? One involves math, one involves logic. It's totally up to you if you're mathematical or if you're logical. Okay? And again, that is a you call, not a me call. Okay? So the mathematical way is using what I like to call a T-chart. Okay? If you are going to follow along with the mathematical way, then the first thing that you are going to do is you are going to pick 5 random x values. You're going to plug those 5 random x values into your function, into your absolute value, and then you're going to get the 5 corresponding y values. Okay? Mathematical. You got to do 5 things. You got to put 5 numbers in. Okay? Okay? So again, this is the mathematical way. Then what you are going to do is then you are going to go to your graph and you are going to plot those 5 points. And you need to look at those 5 dots that you have on your graph and you have to ask yourself, can I see where the vertex is? And if you can, you're golden. If you can't, you gotta plot some more points. So you gotta pick more x values. And you've got to plug those x values in and then plot those points until such time as you can see that vertex. Okay? So if you can see the vertex, you go on to step 3. If you can't see the vertex, you got to go back to step 1 and you got to try more points until you can see it. So it's a lot of guessing and checking and figuring and all that fun stuff. Okay? Then, once you get done with step number 2, now what you do is you connect your 2 points with rays. And that would include then, because then it would say that it goes on forever in both directions. Okay? All right? With me? Let's graph one using the T-chart method. Okay? So step number 1 in the T-chart method was we need to pick 5 random x values. Well, what I would do if it were me is I would pick 2 negatives, 2 positives, and a 0. Okay? So 2 negatives. Give me some numbers. -2. What's another negative value? -1. Let's pick the 0 then right away. two positives. 1 and 2. Okay, love it. Love every part of that. Keeps it nice, keeps it fresh. 1 and 2. Okay. Now what I need to do is now I need to plug those 5 values back into my t-chart. So now we got to do some maths. -2 minus 2. -4, the absolute value of -4. 4 plus 3, 7. So this one here is 7. -1 minus 2. -3, the absolute value of -3. 3 plus 3, 6. So this one would be 6. 0 minus 2. -2. Absolute value. 2 plus 3, 5. 1 minus 2. -1. Absolute value. 1 plus 3, 4. 2 minus 2. 0. Absolute value. 0 plus 3. 3. Love it. Okay. Now we have to plot those points here in step number 2. -2, oh man, look at that. I should do this first. Whoa, whoa. You probably didn't even see it. Yeah, much better. But it was off by a little bit and it was annoying. So -2, 2, 4, 6, 7 is right there. -1, 6 is right there. 0, 5 is right there. 1, 4 is right there. 2, 3 is right there. Do we see the vertex yet? No, we don't. So we got to add another point or some more points. Okay? So I would go by ones. So let's go 1 this way. So that would be to -3. And 1 that way. So that would be to +3. -3 minus 2 is -5. Negative absolute value of -5 is 5. Plus 3 is 8. That one, oh, tap the brakes. Not helping us. Why are you? Why did you give me? Now my name. Hey, sassin' fraffin'. Come on. Here we go. Close enough. Sassin' fraffin'. There. Didn't help us. 3 minus 2 is 1. Absolute value of 1 is 1. Plus 3 is 4. 2, 3, and 4. Did that one help us out? Yes, because now we found our vertex. Okay? So this point right here is our vertex. Okay? So now what we can do is now we can use a straight edge, something straight like a ruler or a ID card or edge of a folder or your what's it called? Planner or your lots of stuff. We can use that straight and we draw in our 2 wonderful and there's our absolute value. Yeah? Now, I like the math. Passionate about it. I know, it's crazy talk. Okay? I like it. But that got really old really fast. Because what if we would have kept going to the left? We would have never found our D. Right? Okay? So there's got to be an easier way. Oh, well, luckily, there is. Okay? So we can use the transformation method because there's a lot of things that get told to us here in the, excuse me, the general form of a graph or of an absolute value. Okay? The first thing that gets told to us is, actually let me move these all around. Okay? Why are those so high? I don't know why those are. That should be. Oh, I know why. Because they should have all been over here. Okay, there we go. All right. The first thing that gets told to us is the vertex. Make sure that that's not down here yet. Oh, look at that. Here it is. What's the vertex? That should be up there. Okay. Well, the vertex, that minimum or that maximum, is at the point H, comma, K. So I look at, oh, what happened there? So I look at these two numbers right there. And that tells me what H and what K is. Now, I will tell you this, that because H is inside of something, be it parentheses or in this case an absolute value, you need to think oppositely. So if I go back to this one, here is that H value. Okay? It looks like -2, but in reality, my vertex is at +2, 3. Okay? Because that one's inside the absolute value, we have to think oppositely of it. Though K is outside the absolute value, so we're going to think normal with it. Okay? Moving the graph up or down, that's going to be K. If K is positive, it goes up. If K is negative, it shifts, the whole thing gets either lifted up or shifted down. And it all comes from K. Moving the graph left or right, that's all from H. Positive is going to move it. So if it's plus X plus H in there, that's going to move it to the left. Again, opposite thinking. If it's X minus H, that's going to move it to the right. all of this other stuff, making the graph be skinny, or making the graph be wide, or making the graph go up, or open down, all of that other stuff comes from A. This number right out there in front. Okay. If A is positive, so now let's talk about that A value. Things that we can sneak out of that. If A is positive, it is going to be a V. If A is negative, it's going to be a mountain. If A is between -1 and +1, it's going to be a wider V. Oops, wrong way. If -1 is bigger than A, or A is bigger than +1, it's going to be a real skinny V. And the bigger we get, the bigger that number is. An A value of 4 is going to be a lot skinnier than an A value of 2. Okay. Here's something that's a little extra, because, you know, I like to take it an extra step. A, as it's written in your equation, bless you, Gesundheit. You gonna make it? Can you drink? You got one. A, as it's written in your equation, is going to be the slope of the right side of your absolute value. Okay? As it's written. The opposite of A is going to be the left side slope. Okay? So, how we use all of that. Okay? So if I'm graphing an absolute value equation, and I'm going to use all of that information, the first thing that I'm going to plot is I am going to plot the vertex, h comma k. I'm going to look at my function, I'm going to plot the vertex, I'm going to think oppositely about h, k is going to be, I'm thinking, normal. Then I'm going to use A to plot more points. The right side slope is going to be A as it's written. The left side slope is going to be the opposite of A. And then finally, just like before, we're going to connect the points with two different rays. Now, I will tell you that the biggest thing that I see that people make mistakes on is they get careless with their rulering or their straight edging, and they make an X. Okay? These graphs are not X's. These graphs are V's. There is a difference between them. Okay? So let's do the exact same one that we just did. This is the exact same one, except now we're going to do it the other way. So if you just want to follow along with the graph that we already did, that's fine. If you want to do a whole new graph, that's fine too. I don't care. Okay? So the first thing that we have to do is we have to find our vertex. Well, our vertex is going to be at the point, I'm going to look here, and I'm going to think oppositely, so that's going to be 2. Then I'm going to look out here, and I'm going to think normally, so that's going to be 3. So the vertex is at the point 2, 3. Then my A value is the value that is out in front of my absolute value. There is nothing out there, so my A value is then assumed to be 1. So the right side slope is going to equal 1, and the left side slope is going to equal -1. So since it's 1, I'm going to go to the right one and up 1 and continue along that pattern. The left side slope is -1, so I'm going to go left and up. And shabam, we got the exact same thing. Okay? Graph this one using any method that you choose right now. Okay, so vertex, where is it at? I'm going to do it the quick method. Where's my vertex at? -6, 7. Okay? So that is 2 and 4 and 6 and 2 and 4 and 6 and 7 right there. Okay? My A value is what? -1/4. That means that the right side slope is -1/4. So I'm going to go down 1 and right 4. Down 1, right 4. Down 1, right 4. Down 1, right 4. My left slope is +1/4. So I'm going to go down 1 and left 4. And that would give me a positive because I'm going in both negative directions. That gives me enough information to graph it. And there you go. Yeah, buddy? Yeah, buddy. All graphing, all the time. So I will hand out graph paper for you now.